Good morning. Some folks asked me to post this up, just some basic stoichiometry, so I'm taking a few moments to videotape this board and explain what was done here so that hopefully it's helpful to some of you. Alright, so this is basic stoichiometry. This doesn't involve limiting. This is simply if you have one reagent and you have plenty of the other reagent. So in this particular case, the original question was, in this reaction, if we have 2 sodium reacting with 1 chlorine molecule to produce 2 sodium chlorides, and we had 92 grams of sodium, how much chlorine would we need? Now, if I said that I had 92 moles of sodium, then obviously I would need half as much because it's a 2-to-1 ratio, 2 sodium to every 1 chlorine, so I would need 46 moles of chlorine. But that's not what I asked. I said if I have 92 grams of sodium, how much chlorine do I need? So, first step, since this equation only relates amounts, not masses. In other words, it's a counting number, 2 sodium atoms, or 2 moles of sodium atoms reacting with 1 mole of chlorine atoms. So, what we need to do is we need to get this to moles. So, in orange, our first step is to go from grams to moles. So we take the 92 grams and we divide by 23 grams per mole. Notice the grams are on the bottom to cancel the grams here on the top. 1 mole of sodium per 23 grams of sodium, so it's 4 moles of sodium. We've used the molar mass to get to the moles. Now, the next step is we're going to go from the moles of sodium to the moles of chlorine. This is where we need the equation. So if we have 4 moles of sodium, I've put the sodium right below here, the 4 moles of sodium. I'm going to use the balanced equation, the ratio of the balanced equation, to find the moles of chlorine. So what we're going to do over here in the green is 4 moles of sodium, 1 mole of chlorine, it's implied that there's a 1 there, to 2 moles of sodium, and that gives us 2 moles of chlorine. Now, if we want to go back to grams, again, we're going to use the molar mass. So going in the last step, we're taking the molar mass of chlorine. Now, the thing we have to be careful is it's Cl2. So we look on the periodic table, and we see that it is 35.5 grams per mole of chlorine. But that's not what we want. All right? We need to use chlorine Cl2, so the molar mass is going to be 71. So we have 2 moles of chlorine times the 71 grams per mole gives us 141 grams of chlorine. So it's 3 basic steps in review. The orange step, any mole problem, what we need to do is we need to come down from the grams to the moles. Then the next step is we use the equation to relate the moles to the moles. And finally, once we have the moles of the thing for which we're looking, we're going to use that to find the grams of the thing we're looking for. Again, that should be labeled. Now, I show it here in 3 distinct steps. The orange is the first step coming down to moles. The green is the second step coming over to moles of the other reactant. And finally, the pink is going back to the grams. We can also do it another way. You may have seen this in your first year chem. You start with 92 grams. This is our orange step. So we're going to do the exact same thing here. 92 grams, 1 mole per 23 grams. Then what we're going to do is convert, since those the grams will have canceled, now we have moles of sodium. So we're going to do the green step and take moles of sodium, moles of chlorine. That'll cancel the moles of sodium. And finally, we're going to do the pink step. So now we're at moles of chlorine. We want to go to grams of chlorine, so we put the moles on the bottom, the grams on the top, and we end up with grams of chlorine. Hopefully this is helpful. I'll post this up as soon as possible.